Hi, I'm Aarush and I'm the project lead. Currently, I'm a rising sophomore at Amador Valley High School, and I joined AI Camp because I wanted to use my previous experience in Python to create a product that can be applied in the real world, and specifically in the subfield of machine learning or AI.
Hi, my name is Aadil. I'm the data scientist. I'm a sophomore at Arabian Mountain High School, and I came to increase my knowledge in AI and programming.
Hi, my name is Cristino, and I'm one of the web designers. I came to AI Camp so I could learn more about web design, about coding and AI in general.
I'm George. I'm a rising senior at Louisville High School in Texas. I came to AI camp to learn more about AI and to see if I can incorporate it in the realm of robotics.
My name's Eddie. I'm an incoming freshman at RIT. I'm interested in cybersecurity, and I came to AI Camp to combine cybersecurity and AI.
Hi, I'm
Oh, I'm sorry. That was my fault.
Hi, I'm Isaac. I'm a rising senior at Lindbergh High School in California. I came to AI Camp to learn more about how to code the algorithms that are in the popular ML Python machine learning algorithms, and also to expand my statistical skills in other aspects of technology.
And finally, I'm Thomas Pelowitz. I'm the data science EST lead instructor, and I'm so proud of my students. So let's get into the meat of this.
So the data set that we chose was the IMDb's top 1,000 movies. We chose this data set because we were interested in movies in general, and we wanted to predict how well a movie does in gross income using like the available features that are listed in the data set. So after we took an exploratory data analysis of the data set, we determined which features of the data set were useful, such as the year of release, genre, rating, etc. And then we plugged in these features into three different data science machine learning algorithms, and then we took the extrapolations and used it as our predictions.
Yeah, so what we really called this model was the Mr.Krabs Machine, and this was because we wanted to predict the performance of any given movie. So we use parameters such as genre, release year, movie runtime, and movie metascore. And we actually have two options for this. So if we entered a certain genre, we could put in like, I think we actually have a preset. Yeah. So we have a preset set already, and if we predicted it, we would get a number. So this movie made $51 million. And we also made an expansion off of this. So we have a rating. So instead of using rating in it, it'll actually use gross in millions. So if we predicted it, this movie got a 7.95.
This presentation is a 3D scatter plot which compares our runtime rating and gross of the top 1,000 movies on IMDb. The white hat represents the predicted values, and the white true is the actual values we use in the data analysis. This graph also reveals that movies with ratings between 7 and 8.5 and runtimes from 100 to 160 minutes actually tend to generate higher revenue. This also offers a bunch of valuable insight for decision making in a lot of movie making companies.
This correlation heat map shows the relationships between different attributes in the heat map. Numbers closer to 1 and -1 show positive and negative correlation respectively. On the X and Y axis, we show all the parameters that we train our model on, such as genre, runtime, and gross. From our data, we actually see a correlation of 0.27 for runtime and rating, suggesting that there is a positive correlation. In conclusion, the heat map provided us with insights into our data to show relationships. Furthermore, we identified a positive correlation between runtime and gross revenue, reinforcing our hypothesis that longer movies have the potential for higher box office earnings.
This graph is a bar graph that compares the average sum of gross of all movies within a genre. As we can see here, it appears that the adventure, sci-fi, fantasy genres on average tend to have made the most money.
First model that we did was the decision tree. Below shows the parameters that we trained the model on. The confusion matrix was made by grid search CVE, particularly for grain of salt, as it's decent but not perfect.
This model is the Gaussian process regressor. Gaussian process regressor is a way to predict things using math. It assumes the data follows a certain pattern and uses a special math function called radial basis function to figure out how things are related. The length scale parameter we chose decides how much nearby things affect each other and was provided through best params. We test how well these predictions are by using some test data called y-test. We train the model by finding the best math values using the train function. Once trained, the model can make predictions on new data, and those predictions are saved in y-hat.
K-nearest neighbors. K-nearest neighbors is one of the models that we chose besides the other two, which allows us to predict a target variable along the data of other points which surround it. Basically, you'd input how many neighbors you'll look through, and then it'll just produce a result based on that. It wasn't as good as GPR, but it still was kind of accurate.
And for our latest expansion, the movie recommender, we created a content-based recommender engine using scikit-learn. How it works is the user inputs how many recommendations they would like and what movie they want to base those recommendations off of. Let's put in 10 recommendations and Star Wars, for example. Then the model searches through our dataset and looks for which points that represent movies are closest to the given movie and the nth dimension. Finally, the model displays the requested number of recommendations.
We have also made a trailer for our website, so let's play it now.
I may have to reshare here.
Eureka, I have finally found what these aliens were hiding. Those pesky aliens have hid this information from the public for too long, but it's finally mine. The resilient raccoons have made the best site on the internet. The site itself involves comprehensive information on IMDb's top 1,000 movies. Their intention was to make a website that was easy to navigate and pleasing to look at. Not even Mark Zuckerberg could make Facebook's UI close to what these aliens are capable of. They created a machine learning model, the Mr.Krabs Machine, to accurately predict their favorite movies' gross revenue. We all know these aliens fancy themselves a good Happy Feet binge watch. I won't lie, these aliens have some fire tastes. The Mr.Krabs Machine has a state-of-the-art Gaussian process regressor built in to judge how popular a project will turn out. You might ask what parameters this thingamajig coding calendar uses to make predictions. Well, it asks the user to input the runtime, genre, release year, audience rating, and critic rating of the movie into the machine and spits out a completely accurate figure for how much it shall gross. Additionally, these silly critters have also included several visualizations for their data along with an in-depth and easy-to-understand analysis. I'm honestly amazed these resilient raccoons could come up with so many visualizations along with an overarching visualization that compares 3 machine learning models they had considered when making the Mr.Krabs Machine. If you thought I was finished, you'd be sorely mistaken. The Goon Squad even went as far as making an extension